Good afternoon, guys. I'm Abbass from Talend. This is the first talk after lunch, so I'll try my best to make it as interesting as possible, so you won't fall asleep. Okay, so today I will be talking about Talend Data Streams and how we've built a product on top of Apache Beam. Let's get going. Just a quick word about Talend. So if you're not familiar with Talend, we're a data integration software vendor. We have at least 10 years in business and everything related to data integration. We're a recognized leader in data integration tools and big data integration with a range of products, with the classical ETL products, the Talend Studio, the Talend Big Data Studio, the open source version, and the commercial version. We have also other products that cover everything in the data integration spectrum, from data quality, master data management, cloud data integration, and other products. If you're familiar with Talend, you most certainly know about Talend Big Data Studio. This is something that we've built some time ago. This is the flagship product of Talend, in fact, right now. It's a big data jobs designer. So you've got this what you call the designer panel, where you can build your big data jobs just by dragging and dropping connectors and processors to complete your pipeline. So you can read from multitude of sources, do all types of processing, and then write to whatever sink you have, like databases, Kafka, files, and like with hundreds of components and connectors available in the palette. So this is our flagship product, Talend Big Data Studio. I'm not going to go on details about the Big Data Studio, but just a couple of words of how we tackled the big data issues and the big data jobs in the Talend Big Data Studio. So the idea is very simple. You build your big data pipeline. Then behind the scenes, we'll go and generate native Java code. So we started with MapReduce. Then we moved on to Spark, so that we cover everything related to batch in MapReduce and Spark. And then came Spark Streaming to support the streaming use cases. So the job is designed. So this is your design phase. You design your job, you drop in components. Once you're done with the design phase, you just click the run button, and behind the scenes, we'll generate the appropriate framework code. And then once the code is compiled, the code can be submitted to a running cluster, like, for example, Apache Yarn, where you can run MapReduce jobs, Spark batch jobs, or Spark streaming jobs. Once everything gets compiled, sent to the cluster, and executed, you can get gather some logs and metrics to follow along the execution. So this is our Talend Big Data Studio. So we've been in the big data business for quite some time. And as anyone who have ever worked with big data, you can recognize some of these challenges as the main challenges in big data. So first and foremost is how fast the big data landscape changed. So as I said before, we started with MapReduce, then came Spark Batch, then came Spark Streaming, and in between, this morning in the opening session, the guys were talking about the different frameworks that we went through to get to Apache Beam. Everything in between, from from Pig, all of these different flavors of trying to reinvent the big data processing. So the landscape is really huge. And trying to build products with this in mind is a very difficult step to go through. Even if we focus on a single product, like, for example, Apache Spark, you've got all sorts of APIs. They started with RDD, then they moved to the short-lived data frame, then came dataset. And Apache Spark Summit is in a couple of days, so maybe we'll get a new API or something new for this time. So it's a really fast-changing landscape. We have to anticipate a lot of changes, even within a single framework. So once we settle down the framework choice, we've got the data formats. And we have all sorts of data formats, from the very simple, like flat files, CSV stuff, to more complicated formats or advanced formats, Parquet, Avro, and everything in between. So that leads us to a very long iteration cycle. So You've got your frameworks, you've got your different data formats. You'll have to do like the cross product between all of the data formats and all of the frameworks. Go through testing, deployment, local testing, and of course testing on a cluster, because testing locally is not sufficient. Once you test locally and everything works, you move to the cluster and you get all sorts of serialization stuff when you're working with the real big data sets. So once you go through all of these steps, well, you get to the real use case. That's why you decided to do big database, because you have some use case in mind. So at the end of this long list, you'll start doing your custom code. You'll start integrating more and more libraries. For example, if you're doing machine learning, you will bring along a whole bunch of libraries to do your processing. So that's what we saw during the time we spent building big data products. And the interesting thing is that how these challenges translate to the everyday developer's life, because at the end we were developers working on building products. So every new framework brings along a new API. We have to work through the API, work through the breaking changes between the different versions, the major versions of this API. And then we get all of these different data formats that we need to test with all of the different frameworks. The iteration cycle is you code, you package, you deploy, you test locally, you test on a cluster, and then rinse and repeat for every combination of data format plus the framework. And then at the end, you get to some custom code and custom libraries that goes along your use case. So this set of challenges, then came Apache Beam. So we've been talking about Apache Beam, so I won't get into much details, but the unified programming model of Apache Beam, the separation between the API and the runners help a little bit in the different frameworks that we have, the different and rapid release cycles. For the different data formats, we have the community contributing IOs, Beam IOs, that should work on different runners, on the different APIs. For the long iteration cycle, we have the local debugging. You can just test on your direct runner. It should be equivalent to what we're testing on other types of runners. And then for the different use cases, you have the different SDKs. We talked about Java, the most complete one, Python, and the new Go SDK. So that's what we saw during our preparation for the new product. So the new product is called Talend Data Streams. It's built from the ground up to leverage Apache Beam. So everything is based on Apache Beam. We have a couple of middleware services to bridge the gap between something that you see on the UI, the interface, and Apache Beam. I'll get to the demo. In fact, I'm just preparing for the demo. So I'll go through the slides, and then we'll go to a live demo of Talend Data Streams. But before we'll get to the demo, I'll go into some technical discussions. So what is exactly Talend Data Streams? So it's a big data pipeline designer. So you'll get this pipeline designer where you can use connectors and components to build your pipeline. Everything is based on Apache Beam pipelines. So everything gets translated to Apache Beam pipelines that you can, that later on we built upon these Apache Beam pipelines to enable some interesting use cases and features. The first one of them is the live preview. This will be the subject of our demo, the live preview feature. The second one of them is that you're dealing with Apache Beam pipelines and the portability guarantees of Apache Beam. So you'll be able to run your pipelines on all of the supported Apache Beam runners. And along these two main features, we have other features like schema on read, support for different connectors, transformation. This is the processing components that go into your pipeline, and the ability to do Python coding right inside your pipeline. So this is a quick overview of Talend Data Streams. So we'll get to the demo in a moment, but just as a quick sneak peek of the Talend Data Streams. So you've got your designer, and you've got your pipeline. Then at the bottom, you've got the preview panel, where you will get your live preview. And at the right panel, you'll get some properties to configure your pipeline. We'll get into more details during the demo. But now we can move on to a bit of technical discussion. So the main idea, at the heart of Talend Data Streams, we have what we call the Beam compiler. And the Beam compiler simply takes a graphical pipeline that you've designed on the UI and builds an Apache Beam pipeline. That's very simple. So your input gets transformed into a P collection. Your output gets transformed into a P collection. And everything in between is a P transform, is a transformation on your inputs towards your output. In fact, using this building block, like translating graphical pipelines into Apache Beam pipelines, opens the way for the next interesting feature, what we call the live preview. So what's the idea behind the live preview? In fact, so up till now, you have two separate phases when you're designing your big data jobs, the design phase and the execution phase. So the idea behind the live preview is to integrate some of the execution feedback right into the design phase. So along the way, you start building your pipeline. You drop, for example, your source, and you start adding more components. What happens behind the scene is that everything you do gets compiled to a Beam pipeline, executed on a sample data set, and all of the results will get back to the UI, so that to give you an idea how your pipeline is going to be executed when you run it on a full data set. So the idea is quite simple. You have your graphical pipeline. We'll just swap the input with a sample of your input, run through the pipeline, compile it, and run it, and then get back the results and show you the results all along the pipeline. We'll see this in action in the demo. So this process, this live preview, is triggered for every change on your pipeline. So for example, you change some properties on your processing components. Behind the scene, we'll compile the graphical pipeline into a Beam pipeline and get the results back to the front end. So this is the first feature that we're going to see in more details during the demo. The second one is the portability of the Beam pipelines. So to go from design to full execution, because we were in the design plus the live preview, it's like design with some execution feedback. Here we go to the full execution. So we've got this Beam pipeline, and we've got the Beam guarantees of portability. So the next logical step is just you'll take your pipeline and you run it on a supported runner. So that's the portability of pipelines as surfaced in data streams. You build your graphical pipeline. Behind the scene, we'll call the Beam compiler, build the Beam pipeline, and then execute it on a supported runner. One last thing is the metrics. So I'm not sure if you're aware of the Beam unified metrics layer on top of all the supported runners. So that comes like for free. When you're running the Apache Beam pipelines on the runner, we can leverage the Apache Beam metrics to show you the execution metrics, regardless of the runner that you're using. So I think I'm done for the slides. I'll get back in a moment. But the most important part is that I'll get to a live demo and show you how things work in Talend Data Streams. It's a little bit tricky because I need to move the mouse pad. OK, so here's the Talend Data Streams. And here's my pipeline designer. So this is the pipeline designer. As you can see, I'm starting with an input. I'm just going to hide this one. I'm starting with a simple input. And this is my preview panel. My input data set is a simple Avro restaurant data set. I've got some metadata about restaurants in New York. So if you ever worked with MongoDB, you'll recognize this data set. So I've got something like the address, the borough, the cuisine, a couple of grades of reviews of this restaurant with the score, the name and the restaurant ID. So as soon as I drop my input on the designer, I've got instant feedback of what my input looks like. Then I can start working on my pipeline. So for example, let's say we're interested in doing a quick aggregation by cuisine. So this is my input. I can just go and select the aggregate component. Bring back the aggregate properties. So you have auto schema detection, so you don't have to worry about different columns on your input data. Let's say I'm going to group by the cuisine. I'm interested in doing a count to see what different cuisines looks like, and then save it. And then here I've got the quick results of what my data is going to look like. So we're working on 50 records of input. That's a sample of your data set. After aggregation, this is what I'm getting after the aggregation. So I'm aggregating by cuisine, and I'm getting the cuisine count. So this is the example of taking the pipeline, even incomplete pipeline, because I don't have a sink for now. I just have the input, the processing without a sink. So this is what the output will look like if I have a sink. So this output will go to a sink, but I'll do that in a moment. So here I have my first processing component. I can go on, for example, and do more stuff. I can take this one and replicate my input. So here, at every step of the design process, I can just click on the preview and see what I'm dealing with. So on this branch, I'll be dealing with the original record. Let's say, for example, I'm interested in a second aggregation. I'll just go add the aggregate component. Let's say this time I'm interested in doing the same, but I'm grouping by cuisine, but instead of taking the cuisine count, I'm more interested in getting like a directory. So I'm going to get all of the streets that have restaurants that specialize in this cuisine, for example. So once I hit the save button, the whole process happens again. We take the pipeline, compile it, get some data, and send the feedback to the user. So, and there it is. So I have my aggregations by cuisine type, and I've got the list of streets, everything in between. One more time, there's no sync, so I'm still in the design phase with feedback from the execution phase through the live preview. Bit. You can add more components. I'm going to do one more replicate to get a third branch here. And you can use like all of the available components. One of them is the Python. You can integrate Python code inside your pipeline. Let's say, for example, I'm interested because here, before moving on to the Python component, I can take a quick preview. So here I'm dealing with the actual records. And in the actual records, I've got some grades. It's a list of grades, and each one of them is a record that has a score. That's a number. Let's say for the sake of this demo, I'm interested in something like calculating the geometric mean for some reason of these different records per restaurant. So I'll copy my code. This is a regular Python code that loops over the components. I just add my Python code. So this component takes the actual record as input. For the moment, there's no output. But as soon as I hit the save button, all the process happens again. I'm compiling the pipeline with the actual Python code, and then in the output, I'll have the results. So here I have my geometric results with the name of each restaurant. I can do more processing. For example, on this branch, I'll go, for example, and add a filter row. Let's say I'm interested only in restaurants that have a rating of greater than 10. The schema is propagated. So here's my geometric score. I'm just interested in restaurants that have more than 10 as a score. I'll save. And I've got instant feedback of how the data is going to look like. So here we're looking at 12, for example, for Wendy's for some reason. Here other restaurants with rating more than 10. So once I'm done with the actual design phase, I can just go ahead and start adding my sinks. So here, I'm going to add a CSV. I'm going to save the result as a CSV. So just to make sure that we're working with the correct data. So this is the cuisine count. Here, we have the directory. So I'm going to get that as some Parquet directory. For my outputs, after my filter row, so here I'm dealing with the geometric mean greater than 10. So I'm just going to add that to the list of my top restaurants, for example. And I have the rejected. All of the restaurants less than 10, I can add them to another data set, for example, just to make sure, okay, all of the scores are less than 10. So I'm done with the design. This is my design phase. Now I can go to the second feature, which is the full run of the pipeline. I can just select my runner and do a full run. And the job is submitted for a full run on the full data set. I can see the metrics in a moment, the execution logs, everything that's happening behind the scene. And the logs will come in, the metrics will come in a moment. Okay, so here are the metrics. I've processed 80 records from the input. Produced, not processed records. And it's still moving on. I'm still writing the output. And I'm done. We've processed like 7,000 records and written 7,000 records. So this is the Beam metrics, regardless of the actual runner we're using. So with this in mind, I think I'm done here. So we still have like 5 minutes, 10 minutes? 7 minutes. Okay, so let's get back quickly here. So we've done with the demo. This is available as the data streams as an AMI on AWS. You can take the AMI. You'll have the slides with the link to Marketplace. It's a free AMI. You just pay for whatever Amazon resources you're using. Okay, if you have any questions.
Test? Yeah. I have one question regarding development. So our problem with these GUI first tools is always that it's hard to actually do then a code, check it in, and do a pull request properly. So how is it solved somehow in the professional version, or?
You'll be able to version your pipelines somehow, but that's in the roadmap. You can version your pipelines and keep them in a Git repository and then get them back as actual pipelines.
And the process would be that people would commit them and other people would then get the repository and open it to review the process, open the tool?
There's some work on sharing pipelines and exporting pipelines, and that's in the roadmap later on.
So I have two kind of unrelated questions. The first question is, can you merge back? So you sort of had multiple sinks there. Can you merge back multiple different branches back into one sink, or is that not a supported thing yet?
Not yet.
Okay.
Not yet, but it's in the roadmap to actually support merging stuff back.
Second question is it an open source project, and what's your pricing model and things like that?
It's not an open source project, but the AMI is free. You can grab it from Amazon Marketplace. You just pay for Amazon resources.
Okay. Thanks very much.
So it's over here, sorry. Oh, yeah, so a link to this guy's question. Have you decided on the sort of proprietary format for, for the pipelines? Yeah.
Yeah, it's still under discussion. It's
because I know you won't be exposing the Java code that you generate, right? That's your IP,
it's
right?
Still in active development. So this is the sneak peek of the AMI. The full product will come next year.
So there's no like switch to Java?
No, it's not like the Talend Big Data Studio where you can see the actual Java code generated.
Okay.
Yeah, thank you. You mentioned AMI, AWS. Do you have plans for the other cloud platforms as well? Do you have?
Yeah, that's the actual final product. Will be a managed service deployed on actual cloud providers.
So multiple cloud providers.
For the start, I think it's Amazon.
Okay.
But that needs to be verified with the product managers.
Sure. Thank
Great talk, thank you. You mentioned that you have this Python feature for the pipelines. Does it actually leverage any portability features of Apache Beam, or is this like an own Python wrapper?
It's just a Python wrapper on the code that you. We're still using the Java API for Apache Beam. Everything we do in Apache Beam, so it's really taking the Python code and integrating it in the process, in the pipeline. So there's no leveraging of the Python SDK.
Okay, thank you. But so you can use your own Python libraries, and so it's not limited to just the code you put into
for the moment it's limited
UI.
for the standard library, but yeah, later on we'll be able to open it for integrating your own libraries.
Okay, thank you.
In fact, I'm here with my colleague Ryan, so if you have any questions, so let us know after the meeting, after the presentation.
Alex?
Okay, thank you. Thank you, guys.